Hi everyone, in this video we are going to review the decision tree model. There is no prerequisite for this video. The goal of this algorithm is to make predictions based on learning simple decision rules. Each decision rule should bring us closer to the desired prediction. They are constructed using two kinds of elements, nodes and branches. At each node, one of the features of our data is evaluated in order to split the observations in the training process. Decision trees are built by recursively evaluating different features and using at each node the feature that best splits the data. The best way to understand how a decision tree works is to first have a look at how it is built. In the following figure, you will see the general structure of a decision tree. You can observe the following components. The root node, which is the node that starts the graph. It evaluates the variable that best splits the data. Intermediate nodes, which are the nodes where variables are evaluated but which are not the final nodes where predictions are made. Leaf nodes, which are the final nodes of the tree, where the predictions of a category or a numerical value are made. Like we mentioned previously, decision trees are built by recursively splitting our training samples using the features from the data that work best for the specific task. This is done by evaluating certain metrics. You can see the metrics that are usually used to solve the different types of machine learning problems. In this video, we will not go into how these metrics are calculated. What you need to know is that those metrics are calculated at each node, for every feature remaining. This metric indicates a threshold. Then, we pick the variable threshold combination that gives us the highest or lower value for the specific metric that we are using fit the resulting children nodes. At the right of the slide, you can see a classification example. The following example is built for the iris dataset, where the goal is to predict a category out of 3 different flowers, using features such as petal width, length, sepal length and a lot more. We can see that the root node starts with 150 samples, 50 samples of each of the 3 classes, and a Gini index of 0.667. Because it's a categorical tree, the lower the Gini index is, the better this metric is. We can observe that at the root node, the feature that provides the best split of the different classes is the petal width at a threshold of 0.8. It results in 2 nodes. One with Gini 0, which is a leaf node. The other node, with a Gini of 0.5, is an intermediate node, where 2 kinds of flower are grouped. Predicting the category or the numerical target value of a new sample is very easy using a decision tree. All you must do is to start at the root node, look at the value of the feature that it evaluates, and depending on that value go to the left or right children node. The process is repeated until we reach a leaf node. When you arrive to a leaf node, depending on if you are facing a classification or a regression problem, those are the next steps. For a classification problem, the predicted category would be the mode of the categories on that leaf node. For a regression problem, the prediction we make at the end is the mean of the values for the target variable at such leaf node. The pros are that compared to other algorithms, decision trees requires less effort for data preparation during pre-processing, such as data normalization and data scaling. Also, missing values in the data do not affect the process of building a decision tree to any considerable extent. It is also very intuitive and easy to explain to technical teams as well as stakeholders. The cons are that a small change in the data can cause a large change in the structure of the decision tree, causing instability. Decision tree training is relatively expensive as the complexity and time has taken a more. They also tend to overfit.